a symmetrical edge section with height 120 mm, width 120 mm, and thickness 20 mm is used as a simply supported beam and carries UDL of 60 kN per meter over a span of 3 meter. Determine shear stress at the neutral axis of H section if moment of inertia about the neutral axis is 5.75 into 10 raised to 6 millimeter raised to 4. Right? So this is the numerical. See, H section is nothing but I section which is tilted by 90 degree. Correct? So I is like this. This is I section. Now when you rotate this by 90 degree, you will get a H section, right? So what he has said is the height is 120, width is 120, so it is a square, and thickness is 20 millimeters. So first I will draw a section of this sort. Let us say this is 120, right? Now the thickness is given as 20 mm. First I will draw the lines like this. Now I'll use thicker lines. So H will have this side, and then thickness is 20 millimeter. We'll have a section like this. Right? So this is my section. Just erase this part. Okay. So and this is my neutral axis. Okay, this is the neutral axis. Let's call this as N A. Right? This is my neutral axis. Now, by symmetry, I know this is the location of the center of gravity G. Now he has given this height as 120, this width as 120, and the thickness everywhere is 20 mm, right? So I'm not going to dimension now because I'm having shortage of time. So let us start calculating or solving this numerically. Now first let us find the moment of inertia, or I'll just copy these two things. The shear stress at any section is given by tau is equal to F by I, A y bar by B. So I'm now calculating all the values. So I is equal to, it is a square section 120 by 120, and you are cutting two rectangles out of it, right? Here we have to use the parallel axis theorem. Okay, so b raised to 4 by 12 minus what does parallel axis theorem? I g plus ah square, right? Now I have two rectangles here, so 2 multiplied by, open a large bracket. Now in this I have bd cube by 12, right? So I'll directly put the values to save time. So this is 120. Now what is the rectangle here? Let me put the values. This is 120 and this side is also 120. This thickness is 20 mm and this thickness is 20 mm, right? So this width is 120 minus 20 plus 20, 40. So 120 minus 40 is 80 mm, right? So again it is bd cube by 12. So b is 80 into d cube. Now what is depth here? See, from neutral axis till here it is 120 by 2, that is 60, and this is also 20 mm. So half will be on the upper side of the neutral axis and half will be the below neutral axis. So 60 minus 10. So this will be 50 millimeters. Depth is 50 millimeters. So into 50 cube by 12. This is Ig minus AH square. Now what is area? I'll put another bracket here. Area is 80 into 50, right? It is a rectangle. This is 80 and this is 50 into h. Now what is the value of h? H is actually from the neutral axis of the section. Where is the location of center of gravity? Now this is 10 millimeters and this is 50. So 10 plus 50 by 2. That is the neutral axis or h value. So I need h square. So I'll put it like this. 10 plus 50 by 2 square. Alright. Now let us calculate this value. 120 raised to 4 by 12 is this much minus 2 into 50 sorry okay, I made 50 into, so I'll make 50 square so that it became 50 cube now, right? Into 80 by 12 minus 50 into 80 into now this is 50 by 2 is 25, 25 plus 10 is 35, 35 square I have to do. So 35 square, close the bracket. So it is this value, and I will truncate to this and make it 7. Okay. I'll take the unit of m raised to 4. Okay. Uh, Now I'm considering a section uh, from the upper fiber anywhere here, right? But above this point, above this intersection of flange and the web. Vertical section is always called as web, and horizontal is called as flange. So this is the flange. The intersection is at this point. So I'm taking somewhere in between this, anywhere in between this. Okay. Or to simplify, let us do it like this. I'll just make some points. This is A. This is B. This is C. See, C and B are on same level, right? But C is on this fiber, right? Above the flange, and B is at the bottommost layer of the web and flange intersection, right? And one more point is D, which is on the neutral axis. So if I find at these points, then below the neutral axis, it will be same. So shear stress at A is equal to 0. There is no material above A, so it will be 0. Shear stress at B, at point B, which is on the web, right? It is on the web. Now here AY bar, see, AY bar is area about this line passing through B. Now I have two rectangles here, right? There is one rectangle here and another rectangle here. So I have to consider both the rectangles, and the height of this rectangle is 50, width is 20. So it is 20 into 50, that is my area, into y bar. Now y bar is 10 plus 50 by 2. I did that here. I'll just copy 10 plus 50 by 2. So okay, meeting is ending in 5 minutes. I'll have to do it little fast. So this is 20 into 50 into 25 plus 10 is 35. Uh, and B here, see, I have 20 millimeters here and 20 millimeters here. So P will be 2 into 20, which is equal to 40 mm. That's the only difference, right? We never took any numerical which is having two sections like this. So here B I have to take like this. Now I have everything for this. You have to just substitute the values, and okay, F I have not calculated. So it is a simply supported beam with UDL of 60 kilonewton per meter, right? So simply supported beam with UDL. I'll just apply UDL here, and this value of UDL is 60 kilonewton per meter. So the reaction at these two supports will be how much? 60 into span, that is 60 into 3, 180 kilonewton is the total load on the beam. So both the supports will carry half of it, so it is 90 kilonewton. And your shear stress distribution is like this. All these things we have done in our unit number 2, so that is why I am not explaining it in detail. Shear stress distribution will be like this. So the maximum shear stress is at the support, and that is equal to 90 kilonewton. So you have to use F as 90 kilonewton in this, right? And you will get the value of shear stress for B. For C, you have to do the same thing, right? At C, the value of B will be equal to this complete width, that is 120 mm. And at neutral axis, you have to consider this rectangle above the neutral axis also, right? So that is how you are going to do it. I'll just take the snapshot